So this month we're going to be looking at something that, if you'll forgive me the pun, is really cool. We're going to have a look at actually some changes of state stuff. It's one of the first things I actually do with a higher level class because a lot of the time they think they know exactly what's going to happen, but there's so much detail that you can pull out from something so simple as freezing. Let's take a look at what can take place if we start off with some deionized water in some ice water. Okay, so to begin with, what I've got here is about 200 grams of ice and about a similar mass of water. I've got some spare ice that I can sort of add in as I'm going along, and I've got a probe set up that's in about 5 ml of deionized water, and I'm going to just be able to just sort of leave this doing its thing as we go down. I'm going to do my best to make sure it's in the middle of the water as we're going along. And I've got about 25 grams of salt, doesn't really matter the exact amount. As I get this going, obviously I'm going to add some salt in. The water bath is going to start dropping in temperature well below zero. I've got a little bit of extra ice that I can chuck in if I need it to. And I'm going to lower in my deionized water with the thermometer, the temperature probe in there. We're going to take a look and see what's going to happen. Now picture in your head what you think might take place and see if you can predict the moment that's going to come up where the first time I did this in front of my class and there was a real sort of whoa moment and it was so fantastic. It brought in so much detail about what was taking place in such a potentially simple change of state. So what I'm going to do is bung in some ice. Is here, that's stirring, bugging my salt, again doesn't really matter, just a decent amount to get going there. And so now obviously I'm going to have a water bath here, which the temperature of which is going to be well below zero. And I'm going to start collecting some data using my data logger. That's good to go. And we're going to lower it in and see what takes place. So I'm just going to nudge my probe so it's in the middle of my water, and unsurprisingly we can see that the temperature is crashing right down here, and as we go down I'm going to zoom in a little bit to see what's going to take place around the zero line, because I think you probably already have an idea what's going to be taking place. So our temperatures continuing to drop, and yeah, obviously we're going to go, oh, it's going to get down to zero, isn't it? And then we're going to see that it's going to plateau off as we go through the change of state. Down to about 5 degrees now. And the temperature is still plummeting. So let's see what happens as we get to around zero and seeing if you can predict where the whoa moment came the first time I did this live in front of a class. So we're getting really close to zero now. What's going to take place? Now that's interesting because the temperature of the water seems to have dropped below 0 degrees. And this is the first point where students who were in my class, they already thought, oh, I've seen this a load of times. I know exactly what's going to take place. Got a little bit surprised. Is there something wrong with the thermometer? Why is the temperature continuing to go down? I thought it was going to sort of level off. Doesn't the temperature stay constantly at 0 degrees when we have a change of state? Now I'm just going to move the graph along to make sure we don't miss out on anything. Okay, you ready for this? What I'm going to do is just start to give the probe a little bit of a nudge and see if I can initiate the change of state, because at the moment the temperature seems to be dropping and there's no evidence of our water inside freezing. So I'm going to give it a little bit of a nudge and see what takes place. How cool is that? So our temperature has rapidly gone back up and is locked onto the zero line. Actually, I'm seeing minus 0.1, so we've got a little bit of obviously some systematic error potentially coming from the calibration of our thermometer, and look at it there, absolutely beautifully locked onto that 0 line. As we track along, and it's going to stay on that 0 line until we've been able to finish the freezing process. And at this point I'm going to zoom in just to show you how well locked in it is. It is actually on that 0 line. And at this scale we're now able to actually introduce a whole pile of new extra learning. So we can actually see at this scale now both random errors and evidence of a systematic error, both in terms of the way that the data is jumping around, the degree of precision to which the probe is actually sort of set, and now we can see step by step that the temperature is beginning to drop again, returning so that it's going to come now to equilibrium, having finished change state with the water bath around it. There's so much learning you can do here, and of course this provides us evidence of the fact that actually bond formation, in this case the strengthening of hydrogen bonds in the formation of a solid from a liquid, is going to be an exothermic process. And I always have some magnets on hand just to illustrate to students the idea that, okay, when we allow these things to come together, energy is released. In the case of magnets, we've obviously got movement and sound, but in our case here, we're talking about thermal energy being released as we form bonds, again intermolecular, not covalent, between our water molecules. And now our temperature begins to drop again. I think there's so much stuff that you can get out of this demonstration. Definitely worth trying, especially early on in a course with perhaps some A-level students or some IB students, as a great introduction to changes of state. There's so much to learn from this demonstration. Give it a try.